today I'll be teaching you how to take derivatives of functions. So first I'll be starting off teaching you how to take derivatives of basic y equals f of x functions in r squared. And this basically says that for every y equals f of x, there is a derivative of f of x for x. Now, over here I've noted there are multiple ways that this can be denoted. There's the basic way in which it says the derivative of f of x for x. There's f prime for x of x, and then there's just basically f prime. So the first example I'm going to give is a pretty basic one. If you have f of x equals ax to some exponent n, f prime of x will be an x to the negative 1. You just take the n, you multiply it by the a, then you subtract 1 from the n. So it's pretty simple from there. So I have an example for my lovely students. If you would mind coming up here, if you can figure it out. You can get whatever color you want. Okay, very good. And then I have two more. You can do those. Okay, very good. Okay, now this is the one that may trick people at times because some may think that she just has like the same number, but remember, because you're subtracting 1 from here, it'll go into the negatives. Okay? So next we have a few identities, and first of which would be if you have two functions, one f of x and g of x, and you're trying to take the derivative of the two of them multiplied together. What you would basically do is you would take the derivative of the first one and then multiply it by the second one, add that to the first one multiplied by the derivative of the second one. Okay? So once again, I have an example for my students, if she can figure it out. And then, of course, since they're both x cubed, it will go into 8x cubed. Okay? Now, next we have another identity, which is basically if you had a function of a function. If you had two functions, then you would have put one inside the other. Okay, so basically if you were trying to take the derivative of f of g of x, you would take the derivative of the inside, multiply it by the derivative of the outside with the second one in the inside. Okay, so for this one, you would leave g of x, whatever it is, alone. You would only take the derivative of the external function. Okay? So that would be almost as if it was a constant. And then I have an example, if you can do it. Very good. So that is not all the identities that have to go with taking derivatives, and derivatives are not limited to simply just basic y equals f of x. It can go into functions in many dimensions, in 3 dimensions, or 4 dimensions, etc., etc. But this is the basic concept, and we can just go from there in another session. Thank you.